I want to show you something I did off camera. I wanted this to match up with a diagram I want to show you. So I did a write erase on a switch and did a little creation. I've got everybody back in the right VTP domain. They're both running VTP version 2, but please notice that the config revision number on switch 2 now is 2, and let me go up a little bit here, and you'll see here on switch 1 the config revision number is 2 as well. So we have a tie in our config revision figure. And what's going to happen though when switch 1, when we're going to create a VLAN on switch 1 we know is going to send an advertisement to switch 2, a VTP add, but when the configuration revision numbers are tied, what's going to happen? Is that going to be accepted or is it not going to be accepted? I did create a VLAN 100 on the switches while you were gone. So right now I'm going to use VLAN 300, and I'm not going to put in any ports into it. That's just it. And now we'll go over to switch 2 and see if that quickly it sees that VLAN, and it does. There's the 100 that I created off camera, and the 300 is right there. So it looks like everything's working fine as far as VTP is concerned, but let's check our show VTP statuses while we're at it and see what we see. Well, we can see the configuration revision number went up to 3 on switch 1. Let me bring the pod back up. And we can see that it went to 3 as well here. So something happened there kind of behind the scenes, right? We didn't get any console messages or anything about the config revision number going up. And let's take a behind the scenes look at what happened there. We created VLAN 300 on switch 1. That's going to trigger in turn a subset advertisement from switch 1, and then the config revision number increments before that advertisement is sent across the trunk to switch 2. So while we started with a tie, both switches had a revision number of 2. When that add was sent, there wasn't a tie any longer. Switch 1 had incremented its revision number to 3, and when it sent the add, that was the actual config revision number in the add. You just don't see that when you're just looking at the switches. Now when switch 2 receives that subset add, then what happened? The add had a config revision number of 3. Switch 2 compares those values and says, okay, my own local config revision number is 2, and the incoming add is set to 3, therefore that must be more recent information. So in that case, the contents of the add are accepted and used to overwrite the receiving switch's existing VTP database. And once that's done, switch 2 will then increment its own revision number. Now, we love this. This is a fantastic value because it's very simple, and the switches themselves, frankly, handle all the work. You and I, the network admins, we don't have to do anything to make this happen. This doesn't make us lazy, it makes us smart. But there is one, I hesitate to say doomsday scenario. I don't want to sound too dramatic, but if it happens to you, that's probably what you'll be thinking at the time, because you have to be very careful to set the configuration revision number to 0 in one particular scenario. And this is a little more real world than you think. This isn't just something I just absolutely made up to show you how this works. Now in the following example, we're going to have a 3-switch network with 2 clients and 1 server. And switch 2 is busy sending an advertisement right now with config revision number 300. The domain is CCNP. The non-default VLANs in use are 10, 20, 30, 40, and 50. And there we go, just that simple. So, nothing wrong here, but now a switch that was at another physical location, maybe out of another client's network, maybe out of a CCNP CCIE practice lab back at our site, our headquarters. It's just taken and inserted in the NP domain. The problem is that the revision number on this switch is 500, and this switch only knows about VLAN 1. It doesn't know any of those non-default VLANs from a hole in the ground. So we have a major issue here, because those clients, before they relay it, of course, they're checking to see if they need to accept this add. And if the revision number is higher, than what it already had, which it is, then it's going to say, oh, okay, this is more recent information. You know, VLAN 10 gone, VLAN 20 evaporated. They're all going to be gone, and then all of a sudden you've got a network only with your VLANs. And even worse than that, or even the default VLANs, 10, 20, 30, 40, 50, they're gone. Now, even worse, switch 4 doesn't have to be in server mode in order to ruin things. Now, I've got it listed as a server here, but it could be a client and still cause the same kind of damage. Remember, I believe in the previous video I mentioned very quickly that a VTP client will send out an advertisement when it first comes into a domain, when it first comes online. Well, that could be the one that causes all the trouble if the revision number is higher than the revision number on the receiving clients. So one way or the other, we're going to end up with a lot of trouble there. Now, the time this is most likely to happen, and it has happened, this is not just some bizarre theory, because I know some of you are probably thinking, well, you know, why in the world would I take a switch from a client site and slap it into the network on another client site? Well, let's just say that switch 4 had been operating there fine and dandy, and then all of a sudden on a Friday afternoon or a Sunday morning at 2 a.m., it goes out. And you know, sometimes you know, the first thing you want to do is like triage. You know, the first thing you want to do is take a critical patient and make sure that person stays alive. Well, if a switch goes bad like that, all you're really thinking about is, I got to get a switch in there. And you may not just have a brand new Cisco switch sitting back at your office in a nice neat box that hasn't been touched yet. And you know, when you're hard up for a switch, you're hard up for a switch. So you might look into your, you know, if your company has an IE practice lab or a Cisco practice lab of any kind for any certification, you just go, hey, I got a switch right there. Or you may even think, okay, I know a client where I can pull a switch out that's not in use right now, and I'll take it over, you know, and I'll just sort everything else out later. You know, I'll sort it out, or I'll let somebody else sort it out, but first we just got to get this client up and running. So you just take that switch and then you just slap it into that network. Well, before you do any slapping there, you better set that config revision number to 0. And I know some of you are already thinking, hey, I'm just going to reload that switch and that's going to be enough. No, it's not going to be enough. Cisco theory tells us there are 2 ways to ensure the revision number is set to 0. You can change the VTP domain name to a non-existent domain and then change it back to the original name, or you could change the VTP mode from server to transparent and then back to server. Now, whichever you choose, don't assume it worked. Verify that 0 in the config registry, the config revision number before you proceed, because the official name of this issue, you'll see it mentioned as a VTP sync issue, VTP synchronization problem, something like that. You're going to call it something much more profane if it happens to your network. Now, let's talk about these advertisements a little more in detail, because the subset ads aren't the only kinds of VTP ads that are flying around our network. Here's a summary of each type. Now, the summary advertisements are sent by VTP servers every 5 minutes or when there's a change in the VLAN database. So it can just be every 5 minutes, or it can be triggered by an event. Now, included in that ad type, you have the VTP domain name and version, that config revision number, of course. There's an MD5 hash code. There's also a timestamp and a number that indicates how many subset advertisements will follow the summary. Now, what about those subset advertisements? They're sent by VTP servers when there is a VLAN config change. Now, the subset ads give more specific info about the VLAN that's been changed, including whether, you know, this is a creation, a deletion, or a suspension. VLANs can get suspended, but we're saving that for future studies. The VLAN type, which frankly is most likely Ethernet out of these 3, but it could be a token ring or a FIDI VLAN. And of course, it's going to give you the new VLAN name and the new MTU value if those values were changed. Now, it would sound to me that we've got all our bases covered with our summary ads and our subset ads. I mean, we've got these things going out whenever there's a change that triggers them, or a summary advertisement is going to go out every 5 minutes, period. So the title of this third ad, a client advertisement request, I'm a little embarrassed to tell you what a client advertisement request is. The name is the recipe, but why do we need them? There are requests from VTP clients for VLAN information. But aren't they getting enough information already, from summary and subset advertisements? Well, these requests come in handy should the client's VLAN database suddenly become corrupt or if it's actually deleted. And rather than wait for the server's ads to be triggered or wait for that 5-minute time period, the client can then explicitly request VLAN information, and the server will answer with a series of summary and subset advertisements that allow the client to rebuild its VLAN database. Just that simple in theory, and actually that does work really well in practice as well. But I would definitely know when the summary and subset ads come and what kind of information they contain. Coming up next, a discussion of the VTP versions. As I said, both switches right now we have are in VTP version 2. We're going to talk about some Cisco best practices. I'll show you again how to change the version. That's the easy part of this. And why you might want to make all your versions the same across your network. I'll see you on the next video with that info.